Hello, welcome to another edition of Sudoku and Variants where I teach you how to solve Sudoku and variants. Today I'm solving a 2, 3, 4 Sudoku. This is where you have to put 2 2s, 3 3s, and 4 4s on the board such that there is no repeats beyond those amount of numbers in each row, column, or 3x3 grid. For example, in this grid, you see that there are 4 4s. Count 1, 2, 3, 4 4s. I cannot put another 4 in that grid. I also see that there are 3 3s. This means I cannot put another 3 in that grid. We're only putting 2, 3, and 4 in this grid. This means that I must put a 2 in that empty square. Because we already have 3 3s and 4 4s in that grid. In the upper left grid. I will look at the next grid over. I see that it already has 2 2s. I know I cannot put another 2 in this 3x3 grid. I will look at column 4 and count the number of 4s. I see 4 4s, so I know that I cannot put a 4 in this column. This means that I can only put 3s, specifically only in those empty squares in the upper middle grid. I then count the 3s and see I have 3 3s in that 3x3 grid here. I already know that I have 2 2s. This means I'm missing the 4. I put in the 4, then count the 4s. 1, 2, 3, 4. I know this grid is complete. I now look at the top row and see that I'm only missing one number. I count 4 4s, 2 2s. This means I must put a 3 in this square. I now look at row 2 and see that I'm missing only one number. I count the 2s and see I have 2 2s. I count the 3s and see that I have 3. This means that I am only missing which number? Yes, I'm missing the 4. I put in 4 and then move on to row 3. I notice I have no 2s in this grid in the upper right region. I also notice that the third row is missing 2s. I also notice that it is missing exactly 1 3. To solve this, I will use cross-hatching technique again. Here I'll look at each column and count the 2s and the 3s. Column 7 is missing 1 3 and 1 2. Column 8 is missing 1 3 and 1 2. Column 9 is missing 1 3, 1 2, and also missing 2 4s. To solve this, I will now look at the middle right grid and still look at column 7. I know that I have to put in both a 2 and a 3. However, this middle right grid has 2 2s in it. This means I must not put a 2 in this square here. That also means that this other square, the upper right grid, must be a 2. It also means that I must put a 3 in the other square. I can look at column 8 and 9 now, but because I know column 9 has more missing numbers, I'm going to focus on column 8. Column 8 is missing a 2 and a 3. We know that the middle right grid already has two 2's. We know that we cannot put a 2 there. This means that the upper square must take a 2 because we are only missing one 2 and one 3. This also means that the other square must take a 3. Here's where I'm going to pause and see where I should focus on next. I'm looking for a spot where I think it will be easy to figure out what number to put in next. The upper right grid is only missing one number. Can you tell me which number is missing? If you said 3, you are correct. I will then look at the middle right grid and ask again which number is missing. Here, the 4 is missing, so I put it in. I will now look at the bottom right grid and try to finish this side of the board. I see that I'm missing exactly 1 2 and 1 4. I will now count the 2's in row 7. 1 2. I know that I cannot put more than 2 2's in any row. Because this grid only needs a 2 and a 4, I know that I must put a 4 here and a 2 there. Here's where it gets really fun and a little bit tricky, but we can do this. I look at column 3. I see that it's missing 1 3 and 1 4. It has both 2's. I will now look at row 4 and count the 4's. Count 1 2 3 4. This means what? If you said this means we must put a 3 in this square, you are correct. Because we're missing only 1 3 and 1 4, the other square must take which number? Yes, it can only take the 4. Now look for a spot that only has 2 missing numbers or 1 missing number. I see it in row 8. Can you tell me which number is missing? If you said the 4, you are correct. I found it by counting all the numbers. Remember, I can only have 2 2's, 3 3's, and 4 4's. Next, I will look at row 6 because I see it is only missing 2 numbers. I count the 2's and the 3's and see that all of them are in. This means I can only put in the 4's. Let's look at the bottom left grid. What numbers are missing there? Did you say 3's? We have all the 2's and 4's, so we only need to put in the 3's. I will now look at row 7 and see that I'm missing 1 3 and 1 4. I will count the 4s in column 5. I see they do have 4 4s. This means I must put a 3 here and a 4 here. I can now look at the bottom row and see if I can figure it out. I look at column 4. I see that I am missing 1 2 and 1 3. I then look at column 5 and see that I'm missing 1 3, but I'm missing both 2s. Column 6, I find that I'm missing 1 2, 1 3, and 1 4. Going back to column 4, I will now look at another row that crosses with row 5. I see that row 5 has 2 2s. I also remind myself that column 4 is missing 1 2. What does this tell us? Did you say that the bottom square must contain a 2? I put in the 2 and go back to the other square and put in a 3. Now I know that the middle bottom grid is still missing a 2 and a 3. I also know that when I look at the columns, they're also missing a 2 and a 3. However, we do know that row 5 has its 2's all in. We also know that 4's are all in column 5 and the bottom middle grid. This means that we're only putting in 2's and 3's anywhere in column 5. Also, we'll now ignore the middle bottom grid and row 9 and instead focus on row 5. I just said that we need to put in only 3 3's and 2 2's. We know that row 5 already has 2 2's. This means we must put a 3 here. This also means that the other empty square must be what? Yes, there must be 2's. This is because we already have 4 4's. And we just put in our third 3. This also means the other empty square must be what? Yep, 2's. Okay, we can also put in the last number in column 5. Did you know what number is missing? Did you say 2? Now let's look at the last empty square in the middle bottom grid. Can you tell me which number is missing? Did you say 3? I put in the 3, and now we'll move on to row 4. Row 4 has a missing 2 and a missing 3. I will have to look at column 1 and column 6 to figure this out. Column 1 has 2 2's. Can I put another 2 here? No, I cannot. What numbers were missing in row 4? a 2, and a 3. Which number goes in the square? I put in a 3 because it already has 2 2's in its column. And it cannot have 3 2's in a column or a row. This means that the other square gets the 2. I will now fill in the last square in column 1 and then move on to column 6 and fill that in. Simply count the numbers and you should figure out quite easily which numbers are missing. You see, I have put in 4's in all of the empty squares. And there we have it. We have solved our first 2, 3, 4 Sudoku, a cool variant. Feel free to like and subscribe. Hope to make the harder Sudokus a little faster, but I do like to give people time to figure it out. So we'll see. Thanks for solving this Sudoku with me. Bye.